So hello everyone, I'm Jason LaGreca. I lead the Higher Education Experience Product Engineering group for the APAC market. I'm really excited to be here. This is a topic that I've been wanting to talk about for so very long with a group of people that are especially passionate about data and data security, especially in Azure and looking at all things cloud for research. So I'll hand over to Felipe to introduce his team. And also then we'll hand over to Steven and Alexandros to sort of give a bit of an introduction about themselves, what it is that they do, and how they can help us unpack this big cloud lofty research data and security topic. It's a very big topic, and we're hoping to try to get through quite a bit today. So Felipe, I'll hand the reins to you for a second.
Excellent. And my screen is sharing okay for everyone?
Yeah, looks good.
At least for those. Excellent. Well, welcome. Thank you, Jason. Thanks for proposing this in the first place. We work closely with Microsoft, and when talking to Jason about the various interesting research projects that we in BizData have been involved in, and working with him in a couple of interesting things that we're working on, we said, hey, why don't we have this conversation where we invite people and discuss current topics, stories. So it's a very, very informal event. We are also learning the ropes of how to use the new Teams live event, and Jason, who knows how to use this thing, has been coaching us, so bear with us as we get it right. And but we, BizData, are an Australian company, but we have presence in a few different places. I myself, and as well as Steven, who joined the team recently, are in New Zealand. But BizData basically has presence all over Australia, and we work with customers all over the world. We've been working with Microsoft for many, many years. And I used to be with Microsoft, and I actually joined BizData because I developed a bit of a passion for research. And when working with researchers and research, I met Alexandros, for example. And we struck a very interesting working relationship. We work with a lot of people. So when Jason and I were talking about how do we invite that can give us kind of a broader perspective and at the same time a deeper perspective, we thought about both Steven and Alexandros for the reasons that you're going to learn in just a minute when I ask them to introduce themselves. So that's me. I'm a director of research and advanced computing at BizData, and basically I work with researchers all over the world to bring their research workflows and projects to Azure. Alexandros, do you mind introducing yourself?
And it's great to be among people I've worked for a long time and consider as friends. Good morning, everybody. Alexandros Papaspyridis. I lead higher education for Microsoft across Asia. This is, I would say, a very interesting job in the sense that, Asia is now leading a lot of the developments that's happening across the world. It just came from the back and it's now leading, but it's also the one that has a lot of diversity on that. So I would be here talking with friends and colleagues about what's happening across the world. I sit on a number of advisory boards, including my alma mater at Imperial College London. So would be great to have a very open conversation around this. Felipe.
Thank you, Alexandros. And then Steven, do you mind?
Okay, hello and welcome everybody. Thanks a lot for joining. I'm Steven Ossont. I guess my background starts when I joined the Microsoft Institute for HPC at the University of Southampton. That's back in the day when CCS was actually a product on premises compute clusters. And then since then I sort of moved on to air quality. Sort of sensor networks, large sensor networks, generating large amounts of data and figuring out not only just how and where you're going to move the data to, but also how you're actually going to gain an insight. So how do you make the data actually valuable? How do you make the data useful for yourself? I often see people just piling data into a nice big pile and keeping their arms around it, and they're very happy with that, but you've got to get an insight. And then after that, I ended up moving on to be a lecturer at the University of Portsmouth, looking after hundreds of students, all running independent projects, most of them cloud-based in various different forms. And along the way, I also looked at moving workloads into Azure. So, for example, space situational awareness. How do you migrate workloads that are detecting collisions between satellites and things into Azure to get it to run slightly faster, better, quicker, all the usual stuff we're used to. Yeah, so I guess that's it in a nutshell. And now I've joined BizData, and so here we are.
That's an awesome summary. Thank you for that, Steven and Alexandros. It's fantastic to have you both here. And I'm just going to start with easy questions first, things that sort of warm up the conversation a little bit. And I'm clearly not the smartest person in the room today, so please, I apologize in advance if I ask anything really silly. But the first one actually will direct to you, Steven. You've got a lot of experience in shifting from on-prem to cloud and doing all of these fun things. Why the cloud? Like, why, as a researcher, somebody that's probably dealing with, I mean, these days terabytes, but let's say hundreds of gigabytes worth of data, why would I go to the cloud, and why would I look at Azure specifically?
I mean, I would answer why not. So let's look at it this way, right? It's the cloud is just another tool in the box. It emerged, let's say usefully, it emerged about 10 years ago. And the way I like to think of it is, you're sitting at your laptop, you got your script, piece of code, whatever it is, you're working away at it. And you get to a point where you're like, okay, I'm happy with that. It runs on my laptop, but you kind of outgrow that. And then you go to a server somewhere and, you're kind of just dialing up the knob a little bit more. And so you run it on a server, maybe you run it on a small cluster at an institution or something, or maybe a national infrastructure cluster. But ultimately, you kind of outgrow all these things. And then you just want to, once you've got it running, you just want to dial the knob as far as possible and go, right, let's get this running. Let's just throw something at it. And it's not just, it's compute and it's data storage. You just want to throw something large at it and get what would perhaps have been impossible or a very long task previously. You need to then be able to get that done. So for me, it's just the next in a progression of tools.
Okay, so that I can see that as a developer myself and somebody that likes experimenting and spending lots of money that isn't necessarily mine. I can see that as being awesome as a researcher. But Alexandros, I imagine you come across some IT teams that are a little bit more, how should we say, conservative in their approach to cloud. How can we help researchers, or how have you helped researchers overcome the barriers of IT, and how have you empowered IT teams to really be the enablers on campus?
Yeah, but this is a great question. Can I chime in something to what Steven said, about, what's the perception today? So, the classical perception of the cloud is, I have this scene from The Matrix where Keanu Reeves asks and says, tank, download me guns, and here's you got this endless parade of guns, So the researchers sometimes think it's, the cloud is just the VMs that you get. It's an endless cache of VMs, which you can get, but you need to pay. However, the cloud is something more. It's the scaffolding in what you do. I call it like how you build a modern skyscraper today. The modern skyscraper has a core, a cement core, and then you start building its floor by floor. And one floor is the security, which you have now. There's high value research because you're doing something which is very, very competitive. And therefore security is needed. You need collaboration because you work with researchers and you want to collaborate, but in a secure fashion, not just sharing passwords. You need to have the data being secure, so you need to build the secure data enclaves. You need to have policies which are not document folders, but you need to have enforceable policies. So the cloud is not VMs, is the scaffolding in which you build your research foundations on that. So let me not go completely off topic to your question, Jason. I think IT, the way that you look at a lot of the universities which are looking at IT a little bit separately. There's the IT out for e-research or academic computing, depending on which part of the world you are. And usually they have been associated about running your cluster. it's very, very important about to see how some of the developments which we have seen, with research software engineers, and particularly in Australia, ARDC is working a lot on trying to give life to these new roles, which are very, very important that help scientists progress the research. So research software engineers, the data stewards. There's complete new roles. So we see now that and the cloud is accelerating this trend, is that you have to build these roles in your team in IT, which are very, very distinct and different from the way you have been looking in conventional IT with the roles of enterprise architects and so on. Now you have research partners, which helping you in the research, and the transformation of your research is contingent on the transformation to these roles.
Very, very, very valuable points. There's a lot to unpack there, Alexandros. We could probably talk about some of those points all day, but I'll redirect the question, more targeted question to Steven, based on experience in working with academics that are just sort of getting started with thinking about the cloud, moving to the cloud. So let's just for a moment pretend I'm an academic doing a research project, and up until now I've stored everything on SharePoint Online. That's the way that we operate. It sounds like not a great practice, but it's actually really common. So Steven, what would be the killer feature, the reason I would shift to the cloud if that's the state that I'm in? I'm not necessarily thinking about some of the scaffolding and some of the higher order functions that like Alexandros was talking about. I'm just talking about dipping my toes in cloud to make my process and research a little bit more efficient. What would I do in Azure to get started, and what would be that knockout feature that would just bang, I'm sold?
Well, I think maybe the feature that people might need is a little bit of security on things, but what is the feature that they want is perhaps slightly different. So for researchers, a researcher just wants to get the end job done, whatever that little task is that needs to be done, whatever the research is, their core, their love for their, for them going to work, basically, their love of their research. That's what they want to get done. Everything else is just something that's in the way of getting the research done. So, I mean, the natural progressions are, sure, you can have a lot of data there, sure, you can throw a lot of compute at it, but what Alexandros says about scaffolding, the cloud is more than that. And to touch on the security thing there, Alexandros mentioned about scaffolding. I always think of Azure as like building blocks, right? But the one thing that's often missed is these building blocks are not just your average household bricks. These are enterprise grade, super solid, super robust, well-tested building blocks that you can use. So yes, you can build a house with it, but sure, you can build a skyscraper with it. These building blocks are stamped and certified all the way through. So merely by moving your data to the cloud, okay, fine, that's a nice world to be in. You've now got more storage, happy days, but you're actually bringing a whole load of things that you get for free along with it. So there's security, there's access, there's a whole pile of other things that you want to do there, and it's that level of control that you start to see the most power. So you mentioned a researcher. Yeah, okay, one researcher, you can kind of see, that's nice. But what if you've got a research group and you now need to share access to a collection of data? And actually, more importantly, you probably want mixed roles to access that data. And if you're, a bit more worried about security, you might actually only want it accessible from particular regions for certain groups of people. And so you can see how you start building upon all of this stuff. And so all of these advantages you get as a single researcher, just picking these industrial grade building blocks and piecing them together.
It's an awesome explanation. I can see how you can start with the basics and then build upon that, and actually over time build up a very rich practice and a best practice for managing your research. So with that, Alexandros, I'll point a question to you. Security, top of mind for universities now for many reasons. Can you give us some examples where an institution has easily, or should I say quickly, moved their practices and policies to better support academics in getting their data into the cloud firstly, and obviously putting into place some of the practices and tools that are available in Azure to be successful.
Yeah. So first, let me put a proof point. You know, we us at Microsoft, we have a very big cybersecurity practices, a $10 billion business. And you know, we are tracking the threats and the attacks against all type of industries, and education is by far the most attacked industry. Why? First, you know, it's easier. You know, you have a heterogeneous environment which you know you don't know. So therefore, you know, it is more easy to have, you know, all these different of threat actors that are coming to you. The second one is you have a lot of guests and so on. So, you know, it's easy to understand that you have a heterogeneous environment, which is very difficult to manage. You know, that you cannot enforce, you know, policies the same way that you enforce in an enterprise where, you know, IT has owns and admins all the laptops, and therefore it's difficult. But also, you know, it's the high value. You know, if you look about the attacks that happened during the time that research labs were scrambling for vaccines during COVID, you understand that this is very valuable. Then second, now universities, of course, work with enterprises, work with defense agencies. So there's a lot of high stakes research that is happening. So it's not like, hey, it's all open, you know, when we care. There's a lot of high stakes things that are happening, which are cutting edge, which are very, very competitive. You know, we live in a interlinked world, you know, where, you know, research is not happening somewhere, it's happening everywhere through collaborations. So therefore, it's very difficult. To your question, again, you know, once you have to enforce a standard, you know, if someone asks you, hey, you know, I want you to enforce this standard, then if it has to do with security or compliance, then it's becoming very, very difficult to do it when your environment, no, I should say impossible, if the environment is heterogeneous, that, you know, involves servers under desks and data moving left and right with disks. Is not possible to say that I'm certified, you know, for compliance on a specific standard. The cloud, through the policies, makes this enforceable. So then this is the big difference, that you're allowed. It's not just pieces of paper in a folder that you have to do that, but it's now something which is enforceable on what do you do. That's the big difference about, you know, how you are able to work with on the security side. And actually what we have seen is, you know, a lot of the customers that are working on biomedical data in the United States, it moved to the cloud because they are not able to comply to the requirements. So cloud is the way that you ensure that you are compliant to the standards. Everywhere else, it's a guesswork which varies over time. It's not only that, okay, you might say that today I'm compliant, but what about tomorrow? If someone, you know, else comes with a different machine and connects to the network, then it's very, very different. You cannot enforce it every day if your infrastructure is ad hoc.
Yeah, and I think just to add to that, actually, what's often lost to people is the collective power here. So if you think about your attack surface, if you're a very good institution, there are probably some security bits on the attack surface. There's some security features that you probably do an excellent job at. There's probably some that you do an average job at, and there may even be some that you just missed for some reason. Now, as soon as you start moving stuff to the cloud, that attack surface, well, at least it's been looked at by more people. And lots of cloud infrastructure, sure, there's all the enterprise grade thought that's gone into the attack surfaces there, but then there are some of the sort of the AI, the automated things that are looking for newer attacks that are coming along, and you get all of this, plus you can have the experience that you've got from on-prem as well. And I would argue that you're going to cover much more of your potential attack surface by shifting over to the cloud, because you just get that experience from a large enterprise and that collective knowledge.
Fantastic points. I feel like I'm hijacking the question, so I'll hand over to Felipe, who I know has some really interesting questions as well, and he's much smarter than I am, so I'm sure he's got some good ones.
So, I guess thank you. Quite alive, but let's try something. So a couple of people have reached out saying that it was a little bit jittery at first. We're, like I said, we're experimenting with Teams live event for the first time. Rashan, who's in charge, very kindly in charge, can you check right now if you unselect me as the speaker if we all come up as a speaker in your view what's in the live event? Because some people are saying I cannot see you anymore. That's what I'm getting on people contacting me on the chat on Teams on the other side. So
sorry, Felipe, what did you want me to try?
Unselect
unselect
me as the speaker, yes.
Yes. You're
Nah, it's okay. We'll
No.
If you don't mind to keep swapping, that would be awesome.
Yeah, it's all good.
So I have a bunch of follow-up questions actually, because I was listening and taking notes and trying to see what I asked, but I don't say I'm gonna play devil's advocate. Obviously, I'm a cloud guy. I used to be in Azure, but I do talk to a lot of customers that they're new to cloud. Some are new to Azure. They've been in AWS. Actually, many have been in AWS or GCP, and they're really interested, particularly in the advanced capabilities in Azure. But they say, we've secured one cloud. We know how to deal with it. We know what data security means in this other cloud. Now we need to deal with this new cloud. But at the same time, and then I talk to researchers, individual researchers, they go, well, we're already using Azure. We're just doing it kind of on the cheeky, on the side. So I wouldn't say playing devil's advocate, but from let's say Steven's experience, because I met him many years back in a Microsoft research conference, and I know he has had to do what many researchers do, which is heroic efforts to get his job done. I would like to know, from your perspective, and going back to the two questions kind of that were asked, which is why would you use the cloud, and also when you had to deal with perhaps IT teams that they have the right to be paranoid, they're supposed to be paranoid, but that paranoia has come in the way. Have you found that A, is worth to go to the cloud in spite of those kind of challenges, and B, that there's been, let's call it a transformation throughout the years where the same IT teams have seen the benefit of the cloud and taking that extra effort, because it is extra effort to adopt it. And I say that, by the way, also because I transferred from America here to this side of the world, and I've seen that transition in some of the institutions I've been talking to. But I'm curious because I know the UK, where you were before, started that a bit earlier on. Does that make sense, the question? So from your perspective, from the individual researcher and research team, a little bit of the history of the transformation, but also the benefits that you were seeing that would push that transformation to happen. And if you want to tell stories about how you went around things, that's up to you as well.
It's not intended as a cheat sheet, but I think let's pick a slightly different example, right? So for me, why did I first go to the cloud? Well, not first, but why did I move one of my projects to the cloud? Well, there was something that was not available on-prem, right? I used MQTT for Message Broker. It was lovely. You throw messages around, everybody's happy. IoT Hub was, to me, a killer feature, right? It's absolutely amazing. You can route messages. It truly scales, and so that was a no-brainer for me. And you can back end the data onto blob storage. So there are lots of things. I think there are lots of things in the cloud there somewhere that you just can't get on-prem, right? So new toys to play with. So perhaps that's the driver for migration to the cloud. But I wouldn't say it was exactly a pain-free process, right? So lots of institutions don't really have a system set up for onboarding people to the cloud. It's nice to hear Alexandros say, hey, you need some team within the universities, because it's, as researchers, we would always start on the free credit, right? Eat up the free credit as far as you can go, and then use your credit card for a bit, and then you get stung a little bit on that, and then you try and claim some of it back, and finance give you that one warning. You can always get away with a warning, and once everyone on the team's had a warning from finance, this clearly isn't sustainable any longer. So Yes, it is nice to see that a lot of institutions now are doing a sort of a hybrid type approach. So there's lots of universities still keep their on-site clusters, and I don't see that going away. So that's here to stay. But for me, the lure is these additional products, these additional features. IoT Hub being the one that I was particularly after. You can happily go along and start using this, and having a team within a university that sort of understands this is really the sweet spot where we need to be. Fast forward many years, what I ended up with is I actually ended up with my own subscription, which is actually the perfect place to be. It was a subscription. It was tied. I had a proposal had gone in, it had been funded, and the funding for that was tied to a cost code, and the cost code was then tied to the subscription. Microsoft sends you the bill I think it was every 3 months or so, and that's actually quite a nice position to be in. But to be honest, that probably took 10 years. So hopefully, when Alexandros is on about having a team within the IT organization in a university or wherever you happen to be, I think that is absolutely the sweet spot to be.
Got it. Yeah. That is kind of what I was after. So thank you, first of all. The other thing that I was thinking about is bringing it back to data security. Like I said, you have kind of the European perspective. Alexandros has some of that. I worked in the US and America for quite a bit, so I had a little bit of that perspective. When I came to this side of the world, when I moved to Oceania, and I started working with the team that works across Asia, I started getting a completely different perspective. Actually, I would say more similar to the European perspective than the American perspective, just because of the way funds move and other things. But I did see that when it came to cloud adoption and comfort with the cloud, we were back. And but talking 8 years ago, back in it's going to cost a lot. A lot of concerns about it's going to cost a lot. So helping people understand that there's ways to control the costs. And yes, it's a different type of investment, capex versus opex. But those stories about the runaway cost at the end that was left turned on and $1 million, the kind of urban legends were thankfully dispelled. The main concern I see right now with my customers is data security. And it's been because of one of the things that Alexandros was mentioning earlier. There's been a lot of cyber attacks in this side of the world, a lot. And it's stuff that already happening in other parts of the world, never stopped in other parts of the world. It's been pretty heavy here. And there's a lot of concerns about data security and due diligence, I would say, and new models put in place to help researchers, I think, and the organization as a whole to keep the data secure. But still, I feel a little bit of hesitance for that reason. Did you see, going back to Steven, I guess, did you see that transition? And then maybe we can move it to Alexandros because he talked to so many other institutions to give us an idea. But did you see that transition as well in the university? Because you said you eventually got your own subscription and you had control over it. That tells me there was a big degree of trust at that point, right?
Yes, yeah, that's a long journey there. And for the data security, perhaps a different way of doing it is that at a university I worked at, we had a building. It was a very nice building, and it was full of researchers and had a miniature data center in it. It had everyone had their own machines, obviously, and laptops, docking stations. People used to just back up and back up to a drive, back up to a USB stick, back up there. It was quite nice. Unfortunately, the building burnt down. It was one of Europe's largest insurance claims, and there were some consequences that came out of this that were kind of shocking. So yes, it's security and safety, right? So a lot of that data was just lost because although it was backed up to a disk somewhere on a drawer in the building that burnt down, it was also backed up to the small data centers in the building that burnt down. But actually, it was wider reaching than that because some of the data centers that we had in the buildings next door were turned off, right? Because then the fire brigade pour water everywhere, it's a bit of a problem, and then the power company comes along and they cut the power, and there's massive inconvenience there. And so there were students that just lost all of their research there. And so security or safety, that's your data that's potentially gone. So storing it somewhere else is obviously very delightful. But since then, in those 10 years, we've got GDPRs come along, and then they're going to ask questions about where is your data? How secure is it? And at some point, you're going to need that rubber stamp on the side of your data that says, yes, it is stored in a data center that complies with, and pick some sort of compliance thing that complies with it. And no matter how good your institution is or wherever you work, you cannot compete with a large data center somewhere, and the physical security certainly around that, you can't compete with that, right? And you won't get certified either. You know, I used to take students on a tour around our data centers because, well, they always wanted to see it. But you know, thinking about that, taking tour groups, you don't get tour groups around Azure. I'm pretty sure you don't anyway, right? So you're not certainly not gonna take a bunch of cool kids around there tripping over the wires and pressing the buttons. So Philip, sorry, I don't know if I answered your question. I digressed a little bit there. Big things the last 10 years: GDPR and getting some sort of certification on the data where it is at rest. What can you reassure people? And of course, longevity. So you apply for, if you get an EPSAT grant, so European funded grant, and the bare minimum after the end of the grant, plus perhaps after publications and things, but you're looking at a bare minimum of 10 years, right? Is that data going to be accessible in 10 years? And that's a tough one. So many institutions will run their own data archiving process, usually it's run by the library or something, and it is quite nice, but the 10 years, is it still going to be there in 10 years? And then you get into the thing that you mentioned earlier, which is price comparisons. I've seen people play all sorts of price comparison games, and I find it very, very difficult, especially in institutions where they're like, well, no, we don't actually pay for the electricity because electricity is free. It turns out actually electricity is not free. Someone is paying for that in your institution somewhere. And so doing that total cost of ownership calculation is quite difficult. So yeah, so there we go.
And I recall, Steven,
I was going to say, yeah, can we go to Alexandros, because I'm sure he has something to say about this. And
first, the photos of from University of Tasmania HPC cluster that went under the water, 1 meter water, and you could see the water on the mark. Yeah, you can have them. You can be insured. What's the disruption in your research? Felipe, what viewpoint you want me to take for that?
Well, you more than I have had those higher level discussions with different universities about security. For me, it's more about enablement, but you have the opportunity to work with the people that their job is to be paranoid. And I know you had a lot of these discussions. You heard kind of Steven's perspective from, the bottom up. Can you tell us a little bit from the?
Yeah, can I take a step back and I say, if you don't think you have a problem, and you truly don't have a problem, stay where you are. Your job is about, if you're a researcher, do your research. If you think that, the research is not at risk because, it's not high stakes and, your computing environment is fine, stay where you are. This is not a conversation about, about this. But, if you think, we see increasingly domains which we have computation is becoming a challenge. You look at large language models, in AI. If you want to do work on AI and large language models, then it's the same about wanting to do some work on fundamental physics and not being in the Large Hadron Collider. You're not going to be able to do it, in your one-room lab somewhere. And it's the same now with the way that computational research does. The need for computation explodes. I was looking at the top 500 list. If you look at I was looking not the top one, which sometimes it's prestige, but I was looking at the number 500. The computational power goes 10x every 6 years. So are you, if you're an institution, are you going to able to maintain this investment? Because sometimes, I hear people saying, hey, the cloud, we keep paying and so on, as if like, you're putting a cluster today and then it's fine, it will be there forever, it will be competitive and so on. It's 10x every 6 years. In a decade, you can be the number one system became the number 500. So you can be off the chart, if you are not maintaining the investment within the usable life, and Steven was so right. He's talking about you have to do the TCO properly, because it's not like, hey, that's done. I'm done with the computation. You need to keep spending. It's no different. You need to do some due diligence. But you might say, hey, I'm a researcher. I don't care. This is something for the vice chancellor and to care about, and the vice chancellor for research. I don't care about. But the triggers for researchers is depending on the field what you do, and the amount of computation that you need, and this is it's really whether doable. You can do this or not, or whether you're trying to commercialize the research. I listened to a very interesting conversation with Dr. Gregory Tijen from Yale School of Medicine, who said the trigger is when they moved their grant, and they got a corporate grant that required them to do 10x the amount of sequencing that they had to do on their original research. He says there was no way we could do it. There was no way our lab could do 10x with the same amount of resources, which we did. So the triggers is when you start thinking about the what's next. And the what's next is, it can have these many different forms of what's next in your research. If your research field doesn't move, stay where you are. It's fine. This is not an exercise for a very static field. But if you have to be on this competitive side, and security and compliance, whether it's HIPAA or GDPR and so on, it's something given now. You have to be a part of it. And you collaborate with researchers with Europe, or you have subjects which you're sequencing in Europe. Then you have you have to follow GDPR. It's not something that happens to this stupid Europeans. It's something that happens everywhere if you are dealing with Europe.
And I think that's so, Alexandros, that's a very, very good point there, because if you're buying a new cluster data center every 6 years, let's just half that. Let's say you do it every 3 years because you want to stay extremely competitive, right? If the fashion is GPUs today and you buy it with GPUs, there's no vendor on the planet that's going to let you return that cluster midway through because you decide to do field programmable processors or something, right? If you change, because research changes, always cutting edge, right? As the technology changes, you need this ability to be flexible, and the idea of just taking your GPU-enabled cluster and handing it back 1 year in because you decided to take a different route on your research is incredible power to have. And I think that perhaps is the killer feature for cloud.
Actually, a really interesting point, Stephen. I hadn't thought of that before, where pivoting midway through research, because research takes time. I imagine, and this is a question to anyone in the room, that would also affect attracting and retaining talent at an institution, right? If you had a team that was maybe not as empowering in allowing you to use these new tools and to get these things up and running and to support you as an academic on your research, that may have a dramatic impact. And I think institutions are becoming more competitive. They're trying to, they're vying for talent and vying for research output and research grants. Maybe that's something that's worth exploring a little bit more. And how do we make sure that we're able to have the best environment for our researchers and that they are empowered to use the best of breed. I mean, with the GPU thing, I mean, you can't even mine Ethereum anymore, so it's kind of redundant having those platforms lying around, right? So Alexandros, I imagine you have those conversations at a high level around looking at talent, looking at skilling, looking at all the things in between when it comes to cloud compute. Anything from your experience that you think might be worth adding?
Yeah, that's great. I would like to emphasize the need of these partnerships and growing the roles. The research software engineers, it's something that is not understood, and and I would say if it's not understood, it's not even respected. But we see the communities of research software engineers and the roles that is being done. In UK has done a fantastic job, but Stephen, that very well. But now Australia is also doing some amazing work there, understanding the roles. What's the role of the research software engineer? What's the job description of the research software engineer? What's the job description for data custodian, and what's the roles? Science now requires to have these support roles, which are very important. It's not just the researchers. We have moved now. I don't know if you've heard about Chris Bishop at Microsoft Research talking about the fifth paradigm of research, which is how to use AI. But if you take a step back, if you want to use AI, you need data. So we're not even talking about the fifth paradigm here. We're talking about the third paradigm. It's how we are able to to get the data and making sure that we can curate the data and understanding them. We see. It's not a conversation about computing. It's a conversation about your data and how, what's the value you're getting out of your data. Whether you are a researcher or whether you are an institution, the key asset you have is the data. The data provides you the foundation for what you do, and it's an asset which needs to be maintained. So, having this mental shift from talking about compute with all the issues which Steven said very, very clearly, and start thinking about what's the value of the data. If you're an institution, this is the number one thing which you should be thinking. Is do you understand what data you have? Do you have the governance mechanism? Can you expose them? Can you follow the FAIR principles, the findable, accessible, interoperable? So do you have this, and can you build these assets, or these assets are lying around with nobody knows where they are? And in particular fields, like you look at bioinformatics, this is the asset. It's nothing else. Having this and correlating them with electronic health records in a secure environment that's what it makes the difference. So making this shift and understanding about where science and engineering, and when I talk about science, I'm talking in a generic way, this is what it makes the difference, whether at an institutional level or your own personal journey.
So if I may follow up, because it's interesting how we've turned into an area that I had personally to change a little bit of how I see things, because I'm a compute guy. I come from high performance computing. So for me, it's always being about the compute. The bigger, the larger, the more parallel. And I would say that 90% of the conversations that we have with customers now are about data. Sometimes I get very excited and start going into the compute side and go, no. Let's first talk about our data. It's about how do we secure it? How do we share it securely? Which is something I would like to touch about eventually, because invariably when we dig deeper, it is being shared, but not securely with the current methods. So the cloud, I think, can change that dramatically, honestly. So it's about the data, but also lately we've been hearing a lot about what you were alluding to, Alexandros, is we are awash in data. Even if we have it secure, we cannot find it. If a new researcher comes that wants to know what else have others done with similar data, good luck finding it, right? So it's becoming a problem of, I would say, a combination of indexing it, making it discoverable. So management, discoverability, and then archival. That's another thing that's coming over and over again. Customers that say, okay, this is genomics data or health data, it needs to be kept for X number of decades. And I used to work in the backup industry many years ago. And one thing I learned is that in 2-3 years, the tape drive that was all the rage 3 years ago is obsolete, right? Because somebody came up with a new, faster, larger capacity tape drive. But if you have your tapes in your secure vault with the tapes of the old one, you better not just replace them with the new ones, because they're not always compatible. In fact, quite often they aren't. So if you're going to put everything in storage now and you say, oh, you're going to keep it for 10 years and you put it on your tape drives, well, you need to keep your tape drives for that number of decades. So it's becoming more and more about that. And only once we tackle that, once we have a rationalize what the what, the how, and the who, we then can have that kind of discussion about compute. And security is just a small part of it, to be honest. And security is changing too, because security was against cyber attacks, for example, right? Or security against someone stealing it. But lately, we're hearing a lot about commercial. It's commercial data that we are custodians of, so we need to keep it secure, because even though we're doing research with it, it is part of a commercial agreement with an institution that trusts us with the data. And the other day we talked about sensitive species, for example, with a research team. They were saying, well, for us, it's about who has access to the data, because we could expose to poachers, for example, a species that's sought after, but that a researcher actually is trying to save by doing that research. So it's very interesting. So that has shifted dramatically for me, to be honest. But with that, the other thing that happened is that I've seen more and more customers saying, I love the cloud. We are not quite there. Can you help us? And my role has shifted from a solution provider to a solution provider plus support. So from that perspective, I would like to hear both from Steven as, let's say, as an individual researcher, and then from Alexandros as a more of a strategic partner to these institutions. What is the right role for a partner in those things? I know I've said a lot, but I'm brought in as a partner, a trusted partner, and I go, oh, compute this and we can do that. I say, no, help us with our data first. What do you think, let's say first, Steven, from a researcher's perspective, from an individual team doing research, what would you expect from a partner? How can we, as a partner, help you feel, that your data is secure and easy to share and everything on the cloud, for example?
Okay, hopefully I can get this. I think so. Back to how I view Azure, right? It's a series of building blocks, and you go into the Azure portal, and you can pick all these building blocks, stick them together in one way or another, and wow, you can make something absolutely amazing. However, there's quite a lot of building blocks. And there's lots of building blocks that basically look the same, kind of in the same field. Do I store my data in this? Do I store my data in that? And so I think the first thing from a partner is like, hey, which of these building blocks should I use? Let's just narrow it down into a handful of building blocks. So maybe I'm still in control of the structure of how these things work, and I'm still building the building. But you say, hey, look, this building block is going to be obsolete soon, or there's a new version coming out, or it actually just doesn't work for the thing that you want. So the first thing is that insight into the history of all the blocks and the ability to restrict it to a sensible set of building blocks. And then, Alexandros mentioned about scaffolding, and this is the sort of the patterns and practices, if we're going to call it that. It's the ability to take a pattern that you've seen time and time again and say to the researcher, you know what, your situation fits a pattern. We'll bring the scaffolding over and say, this is the sort of scaffolding you should be using. And the reason you should be using that sort of scaffolding is because it's compliant with this, it's compliant with that. You'll get these additional features here. You'll get logging, you'll get monitoring, you'll get all sorts of insights. You'll get your archiving, you'll get, and it all comes at a reasonable cost. The cost is kind of neither here nor there. But I think one other thing that we kind of touched on there is people are obsessed with this collection of a big pile of data. And I will always tell you, if you collect a big pile of data, it's just a compost heap. It will eventually just rot and it's of no use to you. The question you should be asking yourself is, why are you collecting the data? All right, so if you understand your circumstance, your problem very well, and it's just dependent on temperature, you record the temperature and you're very happy. But for a lot of people, you don't really know what you want to investigate in the future, and so you start vacuuming up all this data. That is fine, but you've got to ask yourself, why am I collecting the data? And lots of people say, oh, it's because I want to get an insight. I get to know something. I would argue you're kind of only halfway there. It's nice to have an insight into your data. Sure, it maybe helps explain the problem, but I would argue that the end goal is an action, right? That's where you're wanting to go. You collect data so that you can get an insight into the problem, and then you perform an action. And that for me is the key piece. So don't worry about this bit rot, this pile that you've got. You need a data curator, and be careful with archive and everything, but try and see if you can go to this action step. Now, here comes the interesting piece. Because of the way the world is all connected and all the small problems have already been done, all the single person tasks are done, you're going to have to collaborate with someone, and you're going to have to start collaborating on quite large scale. So these are institutions, it's across territories, countries, however you want to view it. These are quite large collaborations. And here comes something that could be quite interesting. You have your big pile of data, and you need to only give particular sets of access to particular groups of people, and more importantly, for a particular length of time. Do always remember this: just because you have the right to look at my data this week, it doesn't mean you have the right to look at my data next week. So the ability to start controlling who has access to data in a sort of a federated type way is the sort of very powerful thing.
So I'm muting because making sure that Steven and I happen to be in the same room, so otherwise you would hear us in extra stereo. I saw Alexandros, you guys don't see it, but I sit in the main console. I see Alexandros, as Steven was speaking. So what do you think, Alexandros? And again, you have a different perspective too, which I love.
I think, I love what Steven said, because, we talked about these large scale projects, like, the Large Hadron Colliders of research, but it's not that, every researcher should ask, okay, great conversation. What's in it for me if I don't want to build the next Large Hadron Collider? And, 99% of the researchers have fall in this. I think there's two ways you can think of it. The first one is, I think what Steven was just saying is look at your data and look at the value of your data and look at the life cycle of the data, the way you need to think. And this is where, Felipe, coming to your question, the value of the partner is there, because you need to start from a problem statement. It's not about the technology, what the technology can do is, but what you are trying to achieve. It's always a very individual journey. And that's the role of a partner like BizData can take, is, help the researchers on their individual journey, which is, I really want to collaborate with these researchers in another, in a corporate environment or in a hospital or whatever. It's your individual journey about what you want to achieve. It's about how you want to take this further. So the key thing is, what's your wicked problem? What is, if you leave your thinking not to be constrained about, your infrastructure today, because, we're always conditioned about the what is possible from what we know, from what we've been working, and say, hey, if these things do not exist, what can I do tomorrow? And really, you can do it next week, and the partner can get you not in this journey, which, step by step, getting things done and driving the research ROI. So it's about, what the value you drive for yourself. And the partners can do that. It's not something which we can do it as Microsoft for every single researcher, because we are a platform company, so we're looking about what we can do generically for everybody. So I think for me, what I would like to say for the people participating today is, just daydream outside the constraints of the environment, about, outside from what the supercomputing center or your cluster or your server under your desk, and say, where do you want to take your research? What's the most difficult problem you have, but you never dare to ask, because simply it will tell you cannot be done. I think the cloud removes the word that the term that cannot be done. It can be done. No, anything can be done. So and then ask your trusted partner about how it's being done, and what do I need to build to make it happen.
Awesome, Alexandros. That was a fantastic way to round out the webinar, and I couldn't have said it better. I mean, there is no end other than your imagination. Really, it's infinitely possible. There are so many things that can be done in the cloud, and I think this was a really good introduction conversation that we had about that. I would invite our participants and anyone that gets to view this after the fact as well to really think deeply about those problems, the things that you could possibly solve if you had a blue sky, if there were no barriers in your way, and possibly invite you to maybe another workshop that we do together, to sort of brainstorm some of those problems and see what we can do together to start solving together. And some great brains in the room here that I'm sure could to help essentially solve that for us. So with that, I'm just cognizant of time, and I want to make sure that folks get to go to their next meetings, which I'm sure are back to back like everyone else. We do really appreciate your time and attendance, and of course the folks on the course, Steven, Alexandros, Felipe, and Rachan. Thank you so much for helping bring this together. It's been a really interesting conversation. I've learned a lot. I'm certainly nowhere near as well versed in the data space as you all are. So again, thank you everyone. I hope you have a fantastic and safe afternoon, and we look forward to talking to you again soon. Felipe, did you have any closing remarks or questions or comments that we want to pose to the audience?
Of course, I always do. If you know me enough. No, thank you everyone. Thank you, Steven and Alexandros, for so graciously being our first guinea pig / attendees. I do love how we ended, because I tend to do that in my workshops with researchers. I try to understand what the workload is, and I have two ways of putting either what would you do if you had a magic wand? That's my magic wand question, right? What would you do with your research? Or I go, what would you do if you had 100 times the stores? And to this day, nobody has told me anything that I go, yeah, no, that we cannot do. Most of the time I go, we can do that right away. So think about that, and it'll be awesome. We can have almost like a brainstorming session around those things. So it's almost like a challenge. I would say, let's challenge people to give us something that you think is not doable within reason, and then let's meet again. So thank you very much, and thanks, Jason, again for the brilliant idea of putting this together. And catch you next time.
Yeah, looking forward to the next one.
Thank you. Enjoyed this.
Thank you very much, everyone.